Okay, let's be real. We've all been there. You've poured your heart and soul into building this awesome ASP.NET Core app. On your machine, it runs like a dream. You deploy it, you're feeling on top of the world. And then, nothing. Or worse, absolute chaos. Today, we're going to break down exactly why that happens and, way more importantly, how you can stop it from ever happening again. You know this feeling, right? That pit in your stomach. It's the classic developer nightmare. You push the code, everything seems fine, you finally lean back to take a sip of coffee, and that's when your phone just lights up with alerts. It's a horrible scenario, and we are going to make sure you can avoid it. All right, so what we're going to do is walk through the 6 biggest, most critical pitfalls that trip developers up when they move an app into the cloud, say onto Azure. But we're not just going to point fingers at the problems. For every single one, we're going to dig into why it happens and give you the real-world fix to make sure it's solved for good. Okay, let's kick things off with part 1, foundational flaws. I want you to think of these as tiny little cracks in the very foundation of your application. They're the kind of problems that can bring the whole house down before a single user even knocks on the door. First up, what I call the configuration chasm. You know the drill. On your development machine, it's perfect. The database connects, data is flowing, it's just beautiful. Then you push it to production, and bam, it all comes crashing down with a nasty SQL exception. The app can't even talk to the database. So what's going on here? Why does it just break? Well, it boils down to something really simple, actually. It's the environment. See, on your machine, your ASP_environment variable is set to development. But out there in Azure, it's production. Your app is looking for that database connection string in a totally different spot, a spot where you, well, never put it. So the fix here, the real professional fix, is to stop relying on local files scattered everywhere. You need to adopt a robust, multi-layered configuration strategy. By using tools like Azure App Configuration and Azure Key Vault, you create one central, secure source of truth for all your settings. That way, your app always knows where to look, no matter what environment it's in. And that leads us perfectly into our next pitfall, vanishing secrets. You deploy your app, and suddenly, users can't log in. You start seeing these totally cryptic authentication errors, like IDX 1063. That's just a fancy way of your app screaming, I can't find the secret keys I need to figure out who anyone is. So where did they go? And the usual suspect here, .NET user secrets. Look, it's a fantastic tool for local development, don't get me wrong, but using it for production is like leaving your house keys at your desk when you go on a trip. Those secrets live only on your computer. They never ever get deployed to the cloud, leaving your production app locked out and completely insecure. Okay, so how do we fix this for real? It's a 3-step dance, and it's the modern, super secure way to do things. First, you take all your sensitive secrets and lock them up tight in a digital fortress called Azure Key Vault. Second, you give your application what's called a managed identity. Think of it as an official, unforgeable ID card inside Azure. Now, your app can just flash its ID to the Key Vault and get the secrets it needs. No more secrets in your code, ever. All right, that brings us to part 2, reality mismatches. And these are the really sneaky ones, the problems that happen because, well, the cozy, predictable world of your development laptop is fundamentally different from the wild, distributed reality of the cloud. Oh man, this next one is so subtle, but it will drive you absolutely insane. I call it the case of the missing view. A web page, a view, that renders perfectly, flawlessly on your local machine suddenly just disappears in production. All you get is a file not found error when you know for a fact the file is there. So what's the reason? It's one of those classic gotchas. File systems. See, your Windows development machine is super chill about capitalization. To Windows, user profile and user profile are the exact same thing. But Linux, which is what's probably running your container in production, Linux is a stickler for the rules. It is case sensitive. If the file is lowercase and your code asks for uppercase, Linux just says, nope, never heard of it. And that brings us to our final act, part 3, the trials of scale. These are the monsters that stay hidden in the shadows when you're just one developer on one machine. They only come out to play when real users start hitting your app hard, across multiple servers. First up, we have a little mystery I like to call the invisible proxy. The scene, your app is sitting behind a big, powerful load balancer, like Azure Application Gateway. You did the right thing, you're forcing all traffic to use secure HTTPS, but your users are stuck. Their browsers are just spinning and spinning in an endless redirect loop. So let's break down what's actually happening here. It's like a game of telephone gone wrong. The user connects to your load balancer securely over HTTPS. The load balancer then turns around and talks to your app over plain old insecure HTTP. Your app, which has no idea there's a load balancer in front of it, sees this insecure request and panics. It says, whoa, redirect this to HTTPS. And we're right back where we started. Endless loop. So how do we fix this mess? It's actually surprisingly simple. There's a magic little piece of code called the forwarded headers middleware. You pop this into your app's pipeline, and it teaches your app to look for special headers that the load balancer adds. These headers basically whisper to your app, hey, it's cool, I handled the security. The original user really is on HTTPS, you can trust me. And just like that, the loop is broken. Okay, next up, the dreaded sticky sessions scourge. Picture this, a customer is on your e-commerce site. They find the perfect item, they add it to their cart, fantastic. Then they go to the next page to check out and, poof, the cart is empty. What in the world just happened? Well, their first request went to server A, but the load balancer sent their next request to server B. And here's the problem. By default, your app has a really short-term local memory. It stores that shopping cart information right there in the memory of a single server. But in a scaled-out world, server B has no idea what happened on server A. It's like having two cashiers who don't talk to each other. The user's cart is stranded on another machine. The solution? You guessed it. We need to give all of our servers a shared brain. A distributed cache, like Azure Cache for Redis, is exactly that. It's a central place where all the servers can store and retrieve session data. Now it doesn't matter which server gets the request, they all look in the same place and can find that user's shopping cart. And now for our final boss, the concurrency crash. This is the one that only wakes up when your app gets popular. Under heavy load, when lots of users are hitting it at once, things just get weird. Data gets corrupted, calculations are wrong, and your app starts throwing these bizarre, impossible to reproduce errors before it finally just crashes. So what's the deal? Well, deep in your code, you've probably got a service that isn't thread safe. The best analogy is a rickety old one-lane bridge. One car can cross just fine, but if two cars try to cross from opposite directions at the same time, total disaster. The real solution is to build a modern multi-lane highway, in other words, design statless services. These services treat every single request as a brand new interaction. They don't remember anything from the last one, which completely eliminates those traffic jams and lets your app scale to the moon. Whew! Okay, so we've navigated those 6 major pitfalls. They're tricky, but they are all fixable. Let's wrap this all up into a nice, actionable checklist you can actually use to make sure your app isn't just running, it's ready for the demands of production. Now, this here is the cheat sheet. This table takes everything we just discussed and boils it down to a super practical guide. It doesn't matter if you're deploying to Kubernetes or App Service or even serverless functions. This is your playbook. It shows you exactly how to handle configuration, secrets, sessions, and scaling the right way for each platform. Consider this your blueprint for building a rock-solid, truly production-ready app. So there you have it, the 6 most common, most dangerous traps that cause beautiful ASP.NET Core apps to fail in the cloud. But look, the real point here isn't just about fixing bugs. It's about a shift in your mindset, from just making it work on your machine to architecting for resilience and scale. So now it's time to go look at your own projects and ask that one crucial question. Are they just built to run, or are they built to scale?